So here is an activity for you guys. So collect small samples of various metals. Put small species, suppose let us take small samples of various metals. Now put small species of samples separately in beakers half filled with cold water. So here we are adding some small pieces of sample separately in the beaker filled with cold water. So now here's the question. Here are some conclusions that can be drawn from this activity. So first of all is, which metals react with cold water? So now think about it. Let me give you a hint that the metals which are highly reactive, they'll react with cold water. So as we studied in our previous slides, sodium and potassium react vigorously with water. So sodium, potassium and calcium. They will react with cold water, whereas magnesium will not react with cold water. So now, suppose we have to arrange them in their reactivity order. So first of all, there will be K, that is potassium. After that, Na, sodium, and after that, calcium. So this is our first conclusion which can be drawn from this activity. Now, our second question is, did any metal produce fire on water? So, as potassium and sodium react vigorously with water, so they will produce fire on water. This is the answer for this question. Now, third conclusion that can be drawn from this activity is, did any metal start floating? Now, answer to this question is calcium and magnesium are two metals that will, after some time when immersed in water, they'll start floating on the water because of the hydrogen gas formed in the reaction hydrogen gas stick to the surface of metal surface. Suppose this is our calcium and hydrogen gas stick to its surface, and thus the metal floats on the water. Okay, Now, as I told you that magnesium will not react with cold water, it will react with hot water. Whereas some metals, they do not even react with hot water, they'll react with steam. For example, metals like aluminium, zinc, and iron react with steam as they do not even react with hot water. They react with steam to form metal oxide and hydrogen gas. So the chemical reaction for the iron reacting with steam, it can be written as Fe plus H2, as steam is the gaseous form of the water. Reacting with it will have the same formula as water. So it will form Fe3O4 plus H2. This is our metal oxide. Now we have to balance our chemical reaction. So it can be balanced as 3Fe, as we have here 3 molecules of iron and 4 molecules of O. So as to balance it. Now here we have 4 molecules and we have 8 molecules of H2. So 4H2. This is how our reaction will look like. Here were some examples of reactions of metals with water. Now let us move to the next slides. Reactions of metals with water. Now, metal react with water to give a metal oxide and hydrogen, as we saw in the previous slide, in the previous activity. In the case of steam, iron reacting with steam, it is producing some metal oxide and hydrogen gas. Metal oxides that are soluble dissolve further in water to give the metal hydroxide. So, what does it mean? Suppose metal plus water, it is producing metal oxide. Now, if our metal oxide is soluble in water, it will again produce metal hydroxide. This is the example of metal hydroxide. So in this video, you can see we have added sodium to the water and it produces fire. We have added sodium to the cold water and it reacts so vigorously that it produces fire upon adding it to the water. So, in the video we saw that it reacts with water so violently that it produces fire sometimes, and it produces oxides and hydrogen. So, in the reaction we can see potassium reacting with water, it produces potassium oxide, along with some hydrogen gas and heat energy, the fire. Similarly, in the case of sodium, it is reacting with water to produce the oxide and releasing some hydrogen gas and some fire. Now, as I told you earlier, aluminium, iron, zinc, they have a low reactivity. So they lie below in the reactivity series. So they cannot react with cold or even hot water, but only with steam. Lead, copper, silver and gold, they do not react with water at all. Doesn't matter if it is in a steam form, if it is hot or if it is cold. So they won't ever react with water at all. So you must remember these examples, okay? Just remember silver and gold, as we wear them in our daily lives also. So because they are the least reactive metal in the reactivity series. So that is why the jewelry is made up of gold, silver. Now reactions of metals with acids. Metal combine with acids to release hydrogen gas and the corresponding salt. For example, metal plus some dilute acid producing some salt and hydrogen gas. For example, here we have taken zinc as metal. While reacting it with dilute acid, it forms a salt called as zinc chloride and some hydrogen gas is released. Similarly, in the case of magnesium upon reacting with dilute hydrochloric acid producing magnesium chloride and some hydrogen gas is released. Hydrogen is not released on the reaction of dilute nitric acid and metals because nitric acid is a powerful oxidizing agent. So hence no hydrogen is produced in the case of HNO3. Now Aqua Regia. What is Aqua Regia? It is a freshly prepared mixture of concentrated hydrochloric acid, that is HCl, and concentrated nitric acid in a definite ratio. It should be in the 3:1. It should always be in this this ratio. It can dissolve gold because whenever gold is reacted with nitric acid alone or HCl alone, it cannot dissolve gold. So Aqua Regia is a combination of or mixture of two concentrated acids which dissolve gold. Now reactions of metals with other metal salts. We studied in the previous chapter in the displacement reaction. So reactive metals can displace less reactive metals from their salt in a solution. So this type of reaction was called displacement reaction, as we saw in the case of copper and ferrous sulfate or zinc, we can say. So let us suppose we have some metal A and some salt solution of metal B. So if metal A is more reactive than metal B, so metal B will be left alone and the metal A will combine and form a solution. So here A metal is more reactive than metal B. Therefore, it displaced metal B. Here you can see the example of, we have iron nail and copper sulfate solution. So here we have iron sulfate solution and copper wire. So when an iron nail is, added to the copper sulfate solution, the copper sulfate solution will lose its color and, the iron will combine and form the FeSO4, whereas the copper will be formed like this. So now it's the time to learn reactivity series so that you can remember which metal can displace the other metal. So this is the order from least to most reactive. Potassium lies on the top of the reactivity series, whereas gold is the least reactive of all. So you have to memorize this reactivity series in order to, to answer such questions like who displaces whom. As in our previous slide, we saw iron is displacing copper. So you can see iron lies above than the copper in the reactivity series. That is why it displaced copper from the solution. Now, here is a question for you all. Why is sodium kept immersed in kerosene oil? We studied it in the previous slide that it reacts with oxygen so vigorously, so therefore it should be kept immersed in kerosene oil. Write equation for the reactions of iron with steam. I wrote it in the previous slide, so this one is homework for you guys. You should memorize the reaction and you should be able to write it on your own. Now, calcium and potassium with water. So, calcium plus water, it will produce now we have to balance our equation as well. So, we just have to add 2 here. So, this is a reaction of calcium with water. So, now potassium plus water producing and some heat as well. As we saw in the video, potassium and sodium when added to water, that produces fire. So it produces potassium hydroxide and some hydrogen gas. Now we should balance our equation as well. So this is a reaction with potassium with water. Now question number 3. Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction when iron reacts with dilute H2SO4. So the answer to this question is hydrogen gas, H2 gas, is liberated when dilute HCl is added to a reactive metal. For example, suppose we have zinc and some dilute HCl is added to it, it will produce some hydrogen gas and it will form zinc chloride. Now we have to write a reaction as well where iron reacts with dilute H2SO4. So iron plus dilute H2SO4, it gives FeSO4 plus H2. What would you observe when zinc is added to a solution of iron 3 sulfate? This is the oxidation state. You will study about this in further classes or maybe in the later chapters. This is the oxidation state. So iron 2 sulfate, write the chemical reaction that takes place. So zinc is introduced to an iron sulfate solution. The color of the iron sulfate solution changes. Since zinc is more reactive than iron, so it displaces iron. Iron is being displaced from FeSO4, resulting a gray precipitate, and a colorless zinc sulfate solution is formed. So we can see the chemical equation for this reaction as well is FeSO4, zinc is added. So now zinc has displaced the iron and Fe is now left alone.